All right. Hello, everyone. Welcome back to Math 154. So this is our 6th meeting together in total for the summer, week 3, lecture 2, as you can see. So we're going to take a few minutes to talk about our whiteboard. We're then going to take a few minutes to talk about that grade book again, and then we'll get into today's lecture, which will mostly focus on 2.3. So just kind of going back over what we've completed, what's up and coming and due, et cetera, 1.2 and 1.3, those regular My Math Lab homeworks, those are due today. Remember, all due times are 11:59 p.m. And yes, if you try and work at 12 a.m., it will have locked you out. This is if you were like submitting a quiz on Canvas and it was 2 minutes late or something, that's not really going to be a big deal. But make sure that that doesn't happen for a test. That would be a big deal that you would not want to happen. So 1.2 and 1.3 due today by 11:59 p.m. 2.1 and 2.2, both of those sections are due on the 15th, and we will finish 2.3. We're going to talk about that section a ton today, so that will be due on the 17th. Then notice that we have 2 Excel files due on the horizon. There's not going to be too many times where I've got 2 listed at once or 2 due back-to-back days, but this is going to happen a couple of times, and it's more likely earlier in the semester than later. Once we get to the point where the project's on deck, which is more than halfway through the semester, I will kind of ease up on the Excels just a little bit, not a lot, just a little bit. So TV loan, we even talked about a file that was similar, not the same, similar to this in class. Also remember that your guided activities have nice little hints and clues about some of this stuff or just some questions. They'll have pictures of the charts that might help you be able to compare to what you have and just know ahead of time, well, hey, that chart's got an extra whole section to it and I don't have that, so that's off. Or maybe my chart has the extra thing and theirs doesn't, so that would be off. So you'd have to go, okay, well, what can I do differently? What can I do differently? So make sure you're trying things differently. Then the next Excel file that'll be due in a week, again, 11:59 p.m., and you still have 5 attempts. These are always 5 attempts. It's just another note that I'm not going to continue to put up. You should get used to that. That's 1.8 BMI. And remember, we talked about making an addition or multiplication table in order to prepare yourself for that, because it's going to help you learn the differences between regular cell references, fixed cell references, whether you're fixing the row, fixing the column, or fixing both. And a little bit of those are needed for this BMI file. But if you're only practicing this stuff for the first time and you don't know what the answers are going to be for these BMI values in a table, you're not going to be able to ask yourself, does it make sense? So that's why we suggest that you on your own do this extra thing to prepare. You don't turn it in, don't email it to me. We covered it explicitly in class. So you'll know what those answers should be, so that'll help guide you along the way. Video quiz 1, again, this is not our first quiz, this is video quiz 1. We talked about that last time. If you don't know what I'm talking about, go back and watch last class's lecture. Remember, you're always responsible for 100% of lectures watched because they're all recorded and put on YouTube. So make sure you do that. Remember, you can handwrite your answers or type your answers. I do not care as long as if you handwrite them that they are neat. Words, sentences, paragraphs, however you want to do this, but do not just copy paste verbatim what the author is saying in these videos. That would be plagiarism, and we don't want to have to call people out for plagiarizing. Put this in your own words, convey the message. Discussion board due today from week 2, and there'll be a discussion board assigned today, so that will be due in a week. I may have said in the past that I usually do the discussion boards due the next class or quizzes due the next class, but that's for fall and spring. Summer, I'm just kind of experimenting with things, and I'm just making everything due in a week for now. This could change, but I don't think it will. I think I'm going to stick with this. Everything's due 1 week later. Please do not start assignments the day they're due. That is a horrible idea, especially for Excels and sometimes for quizzes. I'd say sometimes with quizzes, you can get away with it, but not the Excel files. Please make sure you're starting this stuff if not the day I mention it, maybe the day after. Go ahead and put your eyes on it, then do it again 2 days later. And then hopefully by the 3rd time, you're ready to rock and roll and knock it out of the park. And, maybe you get a 60 on your first attempt, then you get a 70 on your second, 85 on your third. By the time you get your 4th, you've got a B or an A and you're good to go. Is there anything else I need to say. I think we're pretty good. I am going to make sure that I don't hold you over this time. I apologize for that last time. So what we're going to start out with today is I'm going to talk about that gradebook a little more. I have the completed file. I've already emailed it to you. Also, you should have received an email with the schedule and request link for the tutoring services for TCC. Make sure you say you're based out of the Portsmouth campus when you do so. Our tutors are going to be a little more used to our professors. I'm not saying that someone at the Virginia Beach campus couldn't help you, and maybe the schedule in the Portsmouth campus doesn't work for you. Maybe then you go to that, but at least say you're from Portsmouth initially. And again, I did email you that gradebook file, and we're going to talk about one or two of the quirks with it. You'll see it set up completely now and all that stuff. So let's go ahead and get into it. And as always, if you see a date on the screen, when I recorded this, I was just having some old files up, so ignore those. Only use the ones you see on screen at the beginning and the very end. All right. I have kind of finished working on this gradebook that I was talking about with y'all last time, I believe. And I'm going to be distributing this to everybody without any grades in place, so everything will be blanks or zeros. And the yellow spots here, 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 and then these 4 spots are where you will put your grades in. Over here is a column saying what each category counts as, its weight. And then in this spot here, it's just grabbing the averages or the numbers from over there. So whatever number is displayed right here for the average of my math lab, I just then collect it and put it over here to be organized. Whatever is right here, your average for your Excel homeworks, I then collect it over here. It's just a cell reference. Same thing here, whatever you see here will be there. So watch, if I just manually change this to say 4,000, now that says 4,000 and nothing makes sense anymore, so we undo. But you can see the direct correlation. Same with the participation grade, project, midterm, and final. Now, you will note over here that it says we have zeros on the project, midterm, and final, and that's because these are blanks over here. But I have got this extremely long formula to calculate your grade, and it's this right here that is the entire reason that I said I'm not really into making this a project anymore, because Excel's got this weird issue with some products and data values that aren't there. You'll see these little if statements and these things I am not going to explain to you right now. It's a really cool way of kind of like having a switch, an on-off switch. It's basically saying if something's not there, so, oh, there's no grade in the project, then that means I got to undo because I clicked something. Because there's nothing written in the project, it's not going to count that 5% in the bottom, and it won't affect your grade. So even though it says I've got zeros here, you can tell that the final grade is not affected by that. Without those little if statements, it would be. So again, you don't have to come up with this formula. That's not the point of this. The point of this is for you, the student, to keep track of your grades. Now, this is a calculation you should be able to do by hand, just straight up, but this is a great way to keep things organized so you don't have to constantly do that all semester, because who wants to do that? So you will manually put in your MyMathLab grades as you get more and more and more. And as you get more and more, your average will change. Watch this 90.5. Hey, 1.3, I got a 100. So that 90.5 should go up. And it does. And 2.1, I didn't do, so I get a 0 on it, and my average goes way down. And then the next one, oh, I gotta make up for this. So the next several, I get 100s, and my average keeps going up. And then if my MathLab average is going up, my final grade average is going up. Same with Excel, same with quizzes. So each of these yellow columns, this down here is just a straight up old school average of everything in that column. But it's set up, look when I double click this, it highlights all of them, not just the ones that we've completed. That way, as I enter more and more grades throughout the semester, it updates. Oh, I got a 95, updated. Oh, I got a 71, updated. Also remember that I said that I will give you up to 10 points for each MyMathLab assignment. That's the only category, pay attention. It's the only category I do that for. I will give you up to 10 points. If you don't do an assignment, if you got a 0 on it, it stays a 0. If you got 100, it stays 100. So I'm only going to give you up to 10 points. I will not allow any grade to be over 100. So if you earned a 91, then you type 100. If you earned a 95, then you type 100. If it says you earned an 81, then you'll type 91. So again, all right, I do my project, and you know what? I didn't do my project. Ooh, that's bad. I need you to watch this really closely, okay? So I'm going to type a 0. Watch this final grade. That average should go down, but it doesn't. And that's what this memo is about right here. If you have any category that you actually earned a 0 across the whole thing because you didn't do it, you will need to temporarily overwrite the value as something like a 0.1 to see your true grade. So I did not do the project, which means I earned myself a 0. But because of the wackiness of Excel and those things I was talking about, if you put a 0, it thinks it's blank, which means it's not actually accounting for it. So if I didn't take the midterm and I earned a 0 on it, if I didn't take the final, I earned a 0 on it, it still says 90.45. This is actually the same issue as my math lab has. And it's a very difficult issue to get around, even with those little if gates. So the simplest way is to just make that category like a 0.1, a very, very small number, 0.1, 0.2, 0.001, whatever you want to say. So I basically just stopped working in this course. It looks like I didn't do the project, I didn't do the midterm, I didn't do the final, and the course is done. My grade's definitely not that. So watch what happens when I change this final exam to something like a 0.1. Watch my final grade number now. Ooh, 66. So now it's really counting that. And a 0.1 is close enough to 0 to be super accurate. Even if I make this 0.000001, so watch, this is probably going to go down like a 66.34, 32, I don't know. 3.3, I was in the ballpark. So is there really a difference between a 0.3 and a 0.4? No. So this is just something you'll have to temporarily do. Now, you need to undo that though, because if you then, let's say you originally didn't do any quizzes, so you said, all right, I have a 0 here, I need to put that 0.1 here so that everything accounts for it. But then if you actually did start doing your quizzes, this number right here is still going to be the 0.1, and you will have overwritten the formula that I created. So that's why I say temporarily, which means after you do that 0.1 and you see your true grade, you hit undo. That way, those formulas will all still be in place. See, average. If I manually type that as a 0.1, it no longer says average. It's no longer doing anything here. So if I did assignments later, it'd be screwed up. And then you're going to email me and say, Mr. Beckner, can you send me the file again? And I'm going to say, no, you should have paid attention to the instructions. Also, you could just download the file again from the email. So this is why we don't delete our emails from our teachers. Because important documents are in there. Okay, so again, I'm going to be emailing this to everyone. I hope that's an excellent resource. I spent a lot of time putting this together, so I hope you appreciate it, and I hope you never ever email me asking your grade. Because what do we say? We teach you to fish, not give you a fish. Okay. And this is also something that you could play around with and actually redevelop for another class if you wanted to. So if you had a class that only has regular homework and then 3 tests, you could just rename this Test 1, Test 2, Test 3. You'll have to change the percentages, maybe delete a category, but there are ways that you can adapt this for any course. Okay, so back on track. 2.3. And let's not show everything all at once. And I did want one final reminder. This is about the 4th or 5th time I've put this on screen. I know I've said it a lot. But remember, for those fixed cell references, something important for that BMI assignment, something that you should have made an addition or multiplication table to set that up. And warning, if you're not going to do this next Excel file, if you haven't turned any in, you're going to be getting emails from me in regards to this. This is unacceptable. You're going to have to do something at some point. So you fix the column by putting a cash symbol in front of the J. That means that that reference won't move left or right. It's stuck in that column. You fix the row by putting the cash symbol in front of the number of the reference, which means the height will not change. The reference will not move up or down. If you don't want that cell reference to move at all because it's just some random thing off to the side, then you fix both of them. So again, kind of the final reminder of that. Now that we will have turned in the BMI and practiced with the creating an arithmetic table or multiplicative table, I don't think I need to say that again in terms of teaching. All right, so 2.3, proportionality, something that we already spent a good amount of 2.1 talking about.
We talked about how proportions are just fractions set equal to each other. We also said another word for a fraction is a ratio, a top and a bottom. We said that it's a really good idea to be using our words to, before we start writing the proportions out, write apples over oranges. If we were using a proportion table, that seems less important, but it still might be a good idea. It's up to you. But we're going to go into extended concepts of proportionality. So I've already kind of spoiled this bolded note several times in the past, and that's that if two things are in the sense of what we've said so far proportional, which really means directly proportional, it's kind of an extra word you're supposed to throw in there, but most people don't if it's directly proportional. Kind of like if I say it's 70 degrees outside right now, what I'm really saying is it's 70 degrees Fahrenheit. A lot of times when we speak math, we drop some words because they're understood implicitly. It's implied. So all the types of proportionality we were studying back in 2.1 were saying that if they were directly proportional, we just said if they were proportional, then if one thing doubles, the other thing should double. That is the base concept of direct proportionality. We've also discussed how not all pairs of data are proportional. So in the real world, you are likely to have to ask yourself if that previous statement holds true or not. So if you were to double one, does the other have to double? So what this leads into is the group work that you'll have to do. Excuse me. Is right here. All right, so this is page 86, 87, yeah, 86 and 87. And you can see there's 15 questions. So that'll give 15 students opportunities as a base. But if the first student comes in to answer question 3 and and someone else thinks they answered it wrong, then another student can come in and do a threaded response and say, well, I don't think your logic to number 3 is right. Here's what I said and here's why. So again, just because it's 15 or 14 or 13, whatever questions, doesn't mean that's exactly how many students have an opportunity. You have an opportunity to come in and say, yeah, I really like what you said. Or you have the opportunity to come in and say, no, I disagree with you. And quite honestly, there should be disagreement. If we were doing this in class, I always do this assignment in class, and there's always tons of disagreement, especially with ones like number 2 and 4, there tends to be disagreement. Number 7, there tends to be disagreement because they don't want to keep this as a simple concept. I'll explain what I mean there. Number 9, there's a disagreement. Number 12, there's always a lot of confusion because of the phrasing of it, but honestly, it's the same exact question as 11. It's just sciencey sounding. So what are we doing here? Determine which of the following quantities are proportional. And again, someone might say yes, and then you come in and say no. But don't just say yes and don't just say no. Especially if you're responding to someone in disagreement, you need to say why. I don't give credit for just a no. No, and this is why I feel that way. Have a conversation like we were in class. I tried to do some more traditional group work with my MDE class the other day. I know 1 or 2 of you were in there, and I don't think it went very well because of, some people are sitting at work, some people have their kids around and stuff. So as much as I would love to do that, I think I am going to stick to the discussion boards for the semester. All right. My side discussion aside, determine which of the following quantities are proportional. Now this down here, this intuitive definition, I'm not going to make that a question for someone to answer. 2 quantities are directly proportional if when you double one quantity, the answer to that was literally just in the notes on the other screen. If you double one quantity, the other must double as well. That's what it means for 2 things to be proportional. My internet has been a little weird this morning, so if there's any audio issues, I'm going to apologize for that. Hopefully it won't be consistent. Yeah, always fun. I was a little worried about that when my phone, the Wi-Fi signal kept going out about 20 minutes before class. I was hoping it got that out of the way. Okay. And what I've found that is when the audio is lagging, a lot of the times the YouTube recording won't be laggy. at least when I've done the review. If I'm wrong, someone can correct me on that. But if there's ever a time when I'm just laggy the whole time, go back and check their YouTube video, and hopefully it's right. If not, shoot me an email. I won't record a whole class, obviously, but maybe we can figure something out. All right, back on track. The first one has already been done for you, so no one gets to answer number one. Number one is already done. Property tax and appraised value of your house. So this is what you need to do in your heads when you're answering yes or no. Ask yourself, and you might have to think about this as a two-way street. If you double one thing, does the other thing have to double? And asking, if I double the first, does the second have to double? That might not be a logical flow, so maybe you need to ask the question the other way. If I double the second thing, does the first thing have to double? So asking it first, then second, and for number one is a little weird. If I double the property tax, does that mean that the appraised value of the house has to double? Well, that sounds a little weird in terms of how that thing really works in the real world. You should actually ask the question the other way. So you, like I said, you might have to ask it if the first, then the second, or if the second, then the first. All right, so the first one didn't quite make sense. So let's say if I double the second thing, if I double the appraised value of the house, does the property tax on the house have to double? And if you know anything about real estate, which we don't expect you to, which is why this one's been answered for you, yes, if the appraised value of your house doubles, your property tax will double. If all of a sudden the city of Portsmouth says that your house went from $100,000 to $200,000 because of this housing thing going on right now, you better sweet believe your property tax bill the next year is going to double because they want that bread. So they didn't just say yes, they said, all right, doubling the value will double the property tax. So again, doubling this thing causes this thing to double. It's cause and effect. Sometimes you can think of it either way. Sometimes that logical flow is only going to work one way. So for question two, when someone comes in and answers yes or no and says why, they could say, all right, if I double the population of a region, does that mean the area of the region has to double? And they might say, well, okay, yes or no, and I'm not going to answer anything about that. But what they might instead have, if they think that that logical flow doesn't make sense, try it the other way. If I double the area of a region, does the population have to double? And I think you can actually answer that one either way. If you're having a hard time with number two, think about places like New York City or Suffolk and how they're drastically different, and how, you know, if you expand, does that force the population to increase? Or if you increase the population, does that mean you have to acquire more area? Volume of gold and weight of gold, there is some type of relationship between volume and weight. I won't say whether it's proportional or not, and I'm not trying to make it sound more complex than it is. But there is a pretty simple argument between number three. Population of New York City and population of New York State. So if you double the population of New York City, does that mean the population of New York State has to double? Or maybe you need to ask that question yourself, vice versa. Question five, pretty self-explanatory. Question six, think about these tickets are all going to cost the same price. So you're going to the movie theater and it's matinee time, and they don't care whether you're a senior, college, whatever, everybody pays one price. So think about that scenario. Height of a photo versus a width of a photo. This is one where a lot of people could say no, because they could, oh, I can just make this photo as wide as I want, and then your face looks all wacky in it. No, what we want to do is maintain something known as aspect ratio. And that last word I just said is a massive hint about number seven. Aspect ratio means that if you make it wider, you're also going to have to make it taller so that the faces don't look all wacky when you reprint them. So think about, all right, you get your graduation photos, you can get your 3x5s, your 4x6s, et cetera, but you always look pretty much the same in those, right? Okay. Number of accidental deaths in 2005 versus number of motor vehicle deaths. This one right here is, some people will get this wrong, but think about whether these two things are absolutely related to each other or not. Accidental deaths doesn't just mean motor vehicle deaths. This could be someone falling off a building or getting struck by lightning, things like that. Cups of sugar to cups of flour in a pancake recipe. So in Grandma's wonderful pancake recipe, that when she makes them, if she's just making pancakes for you, they turn out the same way as if she's making pancakes for the whole family Christmas morning and she's got to make 50 of them. So think about it that way. They got to turn out the same. Your IQ versus your GPA. I have one word that I'll say that spoils this one: laziness. All right, distance to work versus time it gets to work. Don't think about traffic and different paths you can take. Keep it simple. Number 12 is literally the same thing as number 11, even though it sounds a lot crazier. Distance of a celestial object and the speed at which it's receding from us. Just change celestial object to car and the speed at which it's moving away from us. Okay? Euros to dollars, currency exchange. We're going to be covering an entire section that kind of bases off of this. And it goes into proportional relationships. Spoilers. Sea level change versus the amount of ice melted from glaciers and icebergs. This might be a more challenging one. I don't want to spoil the answer. Maybe Google something about that if you think that it is proportional, or if it's not proportional, but I'm not exactly expecting this one to be right, but have a discussion, have a good discussion. And then miles you drive versus gallons of gas you use. Again, keep this argument simple. Don't think about interstate driving versus city driving versus someone slamming on the accelerator versus someone using their single toe and just barely hitting the accelerator. Keep it simple. Keep these scenarios simple. All right, so that is your discussion board, page 86 and 87, questions 2 through 15. Where am I trying to go? Here. 86 through 87, 2 through 15. All right. So back to our notes. So again, if one thing doubles, the other thing doubles, that's direct proportionality. But we're going to study other types of proportionality besides direct. But let's focus on direct for now. You can set up a proportion to find the constant of proportionality. This constant of proportionality, yes, and you're each doing one question. This constant of proportionality is the number that says, all right, for every one apple, there's 5 oranges sold. In that instance, the constant of proportionality would be a 5 because it's a 5-to-1 relationship. If we said for every 10 euros, you're going to convert that to $1. That is not the true conversion. I'm just making things up. For every 10 euros, you get $1. Then 10 would be the constant of proportionality. It's the thing that you can multiply one of these values by to find the other. Now, I didn't say it works both ways. I said one of them. So there's actually, for each pair of apples versus oranges, there's 2 different constant of proportionalities that you could end up discovering. So in that first instance, I said it could be 5. It could also be 1/5 if you set up the problem different from student A. Now, that only works with direct proportionality, and we will illustrate in writing what I'm talking about later. So K. K is the first letter of the word constant, right? LOL, I know, it's just a hard K sound. But C, it just isn't our favorite variable to use because some people get a little squirrely with their C's and they start looking like O's almost. So I don't know why I don't have it maximized. There we go. So when we talk about the constant of proportionality, the thing that says, all right, for every one of this thing, there's that many of the other thing. That's what we call K. So with these proportions, you can set up a proportion. When 2 things are directly proportional, you can set up fraction equals fraction. We've discussed that in great detail. We've done numerous examples. But there is another way to set them up, and that's what we're staring at right here. Instead of setting up fraction equal to fraction, you can say, all right, if 2 things are directly proportional, if y varies directly with x, so if the oranges vary directly with apples, or if the euros vary directly with dollars, anything like that, if you're told that, or if you've deduced that, then you can write the equation y equals kx. Instead of using y and x, you could use more appropriate letters like E for euro and D for dollar. That's certainly up to you. But we do generally keep the letter K for that constant of proportionality. Now, what you'll be doing is you'll first write this y equals kx. Then you will plug in the first scenario. First case. So like if there's 2 apples, there's 10 oranges. So you'd plug the 2 in for whatever you called apples, the 10 for whatever you called oranges. You solve for K. And then you rewrite the equation. EQN means equation. EQN means equation. So the first thing you'll write is like y equals kx, if you think 2 things are directly proportional. And then to the side, you would say x is the number of apples, and then y is the number of oranges. Maybe you decide to call them opposites of each other. You call x the oranges and y the apples. That's okay. There's nothing wrong with that for direct proportionality, thankfully. It can be for more complicated ones. And then maybe I say, all right, for every 2 apples, 10 oranges sell. So what you do is you make the apples 2, which was x. So we go k times 2. The oranges are 10, which is the y. This is why we write things like this. This is super important. Otherwise, you might put the numbers in the wrong spots. And then you just take this equation and you solve it for k. K times 2 means you would divide both sides by 2. You don't even need to rearrange it. You can. That's up to you. And what you would get is 5 is equal to k. That says for every 1 apple, 5 oranges sell. Now, it's not the other way around. It's not for every 1 orange, 5 apples sell. That wouldn't make sense because it was 2 apples to 10 oranges. So you've got to make sure that you make that statement in the appropriate order. So then what I could do after that is say, well, how many oranges sell if 101 apples sell? All right, so we had a really small store initially. We only sold 2 apples and 10 oranges. A year later, we've expanded our store. We're a grocery store now, and we sold 101 apples in one day. So what you do is you take your equation, that y equals kx, but you plug the k in. So we go y equals 5x. We took this, but we plugged in this number to get this. Because that k value, that 5, will hold true for every single scenario as long as these are proportional. Oops, too far. There we go. So if we sell 101 apples, what do we say apples is? Apples is the x. So we go y equals 5 times 101, which is 505. Now the answer is not just 505, it's 505 oranges. If we sold 101 apples, and this whole concept was that they were proportional, that means we sold 505 oranges. Okay, so we're going to come back to this idea in this example down here. We're going to do one just like that, but I've got it set up. I didn't just pull the numbers out of thin air. But before that, I want to describe the other types of proportionality that you can see in the real world. Not everything in the world is directly proportional. There are tons of things that are directly proportional. Assuming that you continue driving at the same pace, with the same acceleration, or the same pressure on your accelerator more specifically, then if you put 2 gallons of gas in your car, you might be able to go a certain distance. If you put 4 gallons of gas in your car, you'd be able to double that distance. Every time you double the amount of gas you put in your car, you'll double how far your car can go. So that would be proportional. But there are things in this world that do not double as one doubles. So one thing might double and the other thing might half. That's the idea of inversely proportional. So there's a different extra word in front of the word proportional. So if I just say the word proportional, we assume it's what? Direct proportional. But if you throw extra words in there or different words besides direct, it changes the equation. This is not y equals k times x, it's k divided by x. So what this means is, as one thing goes up, the other thing's going to go down. More specifically, as one thing doubles, as x doubles, y halves. Or you could say as x triples y, it goes down by a third, that kind of idea. There are plenty of things in the real world that are inversely proportional. Hold on, give me 15 seconds. Sorry, someone's doing something. Okay, so let's say you need to cover 10 miles. So you know you've got to cover 10 miles. If you increase the time that you want to accomplish that drive in, if you want to increase the time that you want to accomplish that drive in other words, you want to take a longer time, that means you're going to have to slow your speed. Or no one really wants to do that. We're not usually casual drivers, right? So let's say you wanted to decrease the time to make that drive, that 10-mile drive. If you want to get there quicker, that means you're going to have to increase your speed. So speed and time are inversely proportional for covering the same distance, because as one goes up, the other is going to have to go down. If you want the time it takes to go down, your speed's going to have to go up. Or if you want your time it takes to go up for some reason, nice casual long drive, you're trying to, I don't know, take an extra 30 minutes to get home because someone's going to fuss at you when you get there, I guess. I don't know. So if you wanted to increase the time it takes you to make that 10-mile drive, you'd have to slow your speed. So that's the idea of inversely proportional. As one goes up, the other goes down. Going back to the apples and oranges, maybe the store does a sale on apples one week and a sale on oranges the next week. So if the store sells apples for 10 cents, I bet the apple sales would increase in that scenario and the orange sales would decrease, because you're going to have a lot more people buying apples and they're going to go, well, now I don't need the oranges. So maybe there's an inversely proportional relationship there. So this y equals k over x. You will see a couple problems in the homework on this. We're not really going to be focusing on that in the Excel, although we have, believe it or not, seen an equation that uses this idea, but there was more variables in there. We, again, in this course tend to focus more on direct proportionality, but this does pop up every now and then, so understanding the concept is important. You can also have things that vary with the square of something. So when you drop an object from, say, the top of a building or wherever, as it falls, it speeds up. It speeds up due to gravity and the way gravitational forces work. So the distance that object falls is actually directly proportional with the square of time. Now there's the k in there is that 9.8 meters per second squared value, or 16 feet per second squared, whichever one you like. And there's some other little subtle numbers in there, but we don't have to worry about that. We're not getting into that. We're not memorizing that. So what I need to point out is, I said earlier that I wrote x as apples and y as oranges for this direct proportional problem that I just kind of made up on the fly. And I said that you could have labeled them backwards and it would have been fine. With inverse proportions, the same is true. You can decide to call x and y whichever you like. However, with more complex systems, like varying with the square of something or the square root or the absolute value, what you call x and y does absolutely matter. So you would have to make sure that everything is making sense as you're plugging in the numbers. Now, when we give you the sentences like this, Y varies directly with the square of X. Here's the way it works. The thing that goes before the word varies, Y varies, blah, 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 blah. That tells me the Y has to be on a side by itself. So I might say the number of oranges vary directly with the square of the number of apples. So I said oranges first before the word varies. So this Y would have to be oranges. So the thing in front of varies is what goes on the side by itself. Write that down if you didn't already. So again, with direct proportionality, there's a cool feature that the Y and the X are interchangeable as long as you're consistent. With inverse proportionality, same thing. But when you start throwing squares and square roots and absolute values, and you can even have what we call joint variation, so you could have apples, oranges, and bananas, then it starts mattering where you place what variable. Okay, so let's go back to a simpler one, direct variation. So the number end, I'm going to end up bumping this down on the next page to show my work after, but let's read it first. The number of students at a college varies directly, i.e. is directly proportional. So I'm just saying that the phrase varies directly is the same phrase, the same meaning as saying is directly proportional. So that's another word that you can use. The word proportional can it be exchanged with the word varies. So there's some important language to have to understand and remember as well. So the number of students is directly proportional to the number of courses. I think that makes sense. The more students you have, the more courses you're going to have to offer. That at least makes some type of sense. Does it mean that if you double the number of students, the number of courses you offer has to exactly double? Honestly, in the real world, not quite, but it's close enough that we're going to say it's proportional, at least in the sense of this problem. It's true as a base idea, but you'll get a lot of programs where the classes are always booked at 24 students each. Then you get those big lecture hall style classes with 100 students in a class. So glad I don't have to teach those. And then you get graduate level classes where there may only be 5 or 6 or 7 students in a class. So there's a little bit of play with that, but again, we're keeping the idea simple. All right, so when this college offered 75 courses, they ended up with 1,350 students enrolled. So they say, all right, well, we want the enrollment to increase because we want more money, so we'll offer more courses. You'll also have to increase your advertisement. Again, there's bigger picture implications here, but just go with the simple idea. So we're going to go from offering 75 courses to 100 courses, and we want to know how many students under this concept will we end up getting in here. So you can still certainly say, you can do this the old way. You can write a fraction equal to a fraction. Actually, you know what? I want to talk about that last. I want to do the new one first. But all I'll say is you can still use fraction equal fraction where you use words to set up your fractions and cross multiply, etc. But let's try the new setup first. So the new way, that's where we're going to write, well, we saw that it was directly proportional, so we can write y equals kx. That's the first thing we'll do. But we don't want to just do that. Don't you dare just do that. You better establish what is x, what is y. So x is going to be, let's see, the number of students at college varies directly to the number of courses. So since the first thing they said is students and then the words varies or directly proportional, the more common scenario is that that's which the y should be, just kind of going with what I said up here. We said the thing before the word varies or types of proportional, whatever, that's what should be by itself. So let's go with that, even though this is completely interchangeable. So students was the thing before varies or proportional, so that's what I'm going to call y. X then would be the number of classes. I will say this one last time before moving on. You can completely swap X and Y. Your algebra will look a little different, but you will ultimately end up at the same number of correct students if you didn't make any algebraic mistakes yourself. So X, I'm calling the number of classes. Y, I'm calling the number of students. That's how I chose to do it. Then they say when there's 75 courses offered, 1350 students enrolled. So let's plug those numbers in. So the Y was the number of students, so 1350 goes on the left. The K we are not plugging in, we don't know, that's the goal in this step. And there were 75 courses offered. We can just divide both sides by 75. Please feel free to rewrite that as 75K first if you have to. That is up to you. And if you do 1350 divided by 7, oh, I can pull out my calculator. I'm not on the silly mode. 1350 divided by 75. I was just going to say the answer, but here it is, 18. So that says that 18 is equal to K. Again, what that really says is for every, let me do this wrong first. Let me do this wrong and just see if it makes sense that it's wrong. So again, I'm pulling out the red for wrong for a minute. So for every one student, there's 18 classes, question mark. If you think about it in the real world idea, that doesn't make sense. For every one student, that college has 18 classes available. Well, I certainly hope that student's taken all 18 classes at least. So that means if you had 2 students, the college is offering 36 courses for a total of 2 students. So writing that statement definitely doesn't make sense. So let's get it right now. It really should have been for every one class, because it's for every one of the X value. That's the way it works. For every one of the X, there's K of the Y. So for every one class, there's 18 students enrolled. That makes a lot more sense intrinsically. So our equation is now no longer y equals kx. It is now and forever, ever, ever for this problem, y equals 18x. The k is 18. That is fixed. It will not change. So now what we do is we plug in that third scenario. How many students would there be if the college offered 100 courses? Courses or classes, that's the x. So we're going to make the x equal to 100. So we get y equals to 18 times 100, which is 1800. The answer is not 1800. That is not a quantitative reasoning answer. It's 1800 students. Does that make sense? Well, when it was 75 courses, we had 1350 students. The number of courses went up from 75 to 100. It didn't quite double, so the number of students should not double. So doubling 1350 would be 2700. We got 1800, so that's less than doubling, but it at least did increase. It went from 1350 to 1800. So yes, I would say that makes sense. Okay, so what about the alternative way? So this was the new way. And what color do we like? Let's go orange. And I'm gonna need to do this. All right, so the old way, and by old, I mean from 2.1, it's not that old. So the old way was where we write a fraction equal to a fraction, we cross multiply and we solve. But before we do any of that, we use our words. So what words seem to kind of help us talk here? We have students and we have courses or classes. So you could write students over classes, or you could write classes over students. My internet looks like it's being silly again. I'm gonna pause for 10 seconds and hope that that passes. Okay, fingers crossed. So again, the two things we're talking about are the number of students and the number of classes. You could use the word courses. You can put either one on top, either one on bottom, just be consistent. I'm gonna put students on top, and then I'm gonna put courses or classes bottom. So when I write my fraction equal to a fraction, I gotta make sure the student numbers go on the top and the classes go on the bottom. For each fraction, that's going to be a scenario that's paired. So when a college offers 75 courses, there's 1,350 students. 1,350 is the students, so top. 75 courses is the number of classes, so bottom. How many students would there be when the college offers 100 courses? So top or bottom, where's the 100 go? What's classes? So bottom. The number of students is unknown, so you can call it whatever letter you like. I call it X. You're going to cross multiply, and you'll get 1,350 times 100 is equal to 75X. This is just a colon, by the way, which is 135000 equals 75X. You're then going to divide both sides by 75. Let's see what we get. 135000 divided by 75. Holy cow, we got the same answer, 1,800. 18, oops, wrong color. What was X though? We should really say this is 1,800 students. The same exact answer. So in the real world, does it matter which way you set it up? Nope. So why am I teaching you this new way then? Why don't I just teach you one thing? Because I love multiple methods, because multiple methods run this world. This y equals kx setup, this is awesome if you then had to go through another 200 or 300 scenarios. So maybe your boss says, all right, I want to know how many classes we need to run. I want to know how many students we'll have if we make 105 courses. Well, how about if we make 107 courses? What if we made 23 courses? Well, what if we did 1,000 courses? Well, what if we made 7,902 courses? We're really going to expand. What if we only offered one course? So your boss comes to you and says, I need you to do these 10,000 scenarios. This cross multiplication would have to be done 10,000 times. That sucks. So this is not efficient. This y equals kx, once you have this y equals 18x, you could just type that in Excel and then use cell references and fill the formula down, and you would have all your 10,000 or however many answers I said within seconds, right? So this is about efficiency. Yes, you can still just do fraction equals fraction. It'll work all day long, but if you've got to do a bunch of these, it's not efficient, whereas the y equals kx is wonderfully efficient. Let me go one last time, and we're going to do this alternative new way. So I chose to do the X was the classes and Y was the number of students. Let's still do Y equals KX, but now I'm going to swap those. X is going to be the number of students, and Y is going to be the number of classes. Let's see what happens if we do it this way, if we still get the same answer and what looks different. Okay, so we said when there was 75 courses, there were 1,350 students. So 75 courses, that's now the Y, so the 75 goes on the left. The K times the 1,350 is now on the right. So you're going to divide both sides by 1,350 to solve for the K here. Now, when you do that, you're going to get some ugly decimal value, probably, right? Let's see what we get. 75 divided by 1,350. We get 0.0555. Don't write that for a K. That's a bad idea. What you should instead do, and it would be okay if this wasn't a continuous fraction, but it is. So instead, what you should just do is, okay, well, reduce them instead. And you could reduce the 75 and the 1,350 by 5 or by 25, all sorts of options. We already know that 1,350 divided by 75 is 18. So that means if I reduce this completely, what you'll get is 1 over 18 is equal to K, if you reduce that as a fraction. So then what that means is our equation is now y equals 1 over 18x. Look at this versus this. This is what happens, and this is not a problem. This is just what happens when you do your X's and Y's differently. If one person calls X the number of students and the other calls X the number of classes, one student's going to have their K be an 18 and the other would be 1/18th. Or for that 1 apple to 5 orange problem. So my K was a 5, but someone swapping what they call X and Y, their K would be 1/5 instead, or 0.2, since that's a perfectly fine decimal. So you might be thinking, oh, well, this isn't right. But it is, because your concept of X and Y flip-flops. So check out what happens when you plug in the 100 courses. So now what we do is, red. So we take our Y equals 1/18x, but we're going to plug in the 100 courses, which was the Y. So we get Y equals 1/18x. The way we solve this equation, the 18's in the bottom, so we multiply both sides by the 18. We're used to seeing 18 times x, so we divide. Well, if you see a division, you multiply. So those 18's cancel, giving you 1800 equals x, which was the number of students, the same answer. So we just did the same problem 3 different ways, and we got the same answer each time. One times anything is the anything. The 1 is still there if you really have to see it, but no one likes writing that 1. All right. Still not quite done, because I'm going to, I don't want to say that phrase. I am going to run this problem into the ground. So we're leaving the horse alone. We're going to run this problem into the ground. Let's show you one last thing. Using fractions to find the K. So we used the equation to find the K. We plugged things in and that was fine. We showed the old way where we did fraction equal to fraction, and we skipped finding out what the K is, and we just went straight to finding the number of students, which is perfectly fine. But you can still find the K using this fraction setup, but what you do is you don't plug in the second scenario's value. You just use this as your fraction instead and reduce it as much as possible. So you just use one scenario, that's a C, and your words, your labels. So you put courses over students, or students over courses equals, run through the first scenario, which was 75 classes for 1,350 students. And then what you do is you cross multiply, which will give you 1,350 courses times the number of courses. That's not 1,350 courses, equals 75 times the number of students. Make sure you know these aren't labels. Those are basically variables. And then you can just choose to solve for one or the other. If you solve for courses, if I solve for courses, let me run this through first scenario. So A, solve for courses. So you take the 1,350 times the number of courses equals the 75 times the number of students. If you want to solve for the courses, you divide both sides by 1,350. We already know that fraction reduces to a 1/18, and you'll get, I ran out of room, didn't I? That's okay. I'm going to do that here. That's 1/18, so the number of courses is 1/18 of the number of students. Or the second scenario, so that says if you know the number of students, you can just plug that in here, multiply it by 1/18, and you'll figure out how many courses you need to offer. Or if I took that original thing and I solved for the number of students, which would have been more relative to the problem we actually had. So we take the 1350 times the number of courses, set it equal to 75 times the number of students. This time we'll instead divide both sides by the 75. And we know the 75 goes into 1350 18 times. So 18 times the number of courses should be equal to the number of students. And look how these same numbers ended up popping out. Those would be the Ks in each of the scenarios. So in the first scenario, I've called Y the number of courses. In the second scenario, I've called Y the number of students based on what's by itself. That's your K. Again, just depending on which scenario you prefer, which one you prefer to solve for. For this problem, the right-hand scenario was easier, but for another problem, maybe the left-hand scenario was easier. Again, you don't need to master all of these different ways to do this. What you do need to do is understand how to do at least one of them, hopefully two of them. How are we on time? 15 minutes. I think we can do this. Page 92. All right, do this. This. Here we go. Is that going to be enough space? There we go. All right, so this is page 92 of your guided activities. Let's see how many we can rock out in the time we have left over. And we'll just call it a section with where we stop at. And I've got things, I can't read the top right now, sorry. Given the following proportional quantities, so they told us they're proportional. We don't have to determine that. And again, in terms of my Math 5 homework, that's generally the case. You don't need to determine that. That's the real world issue. Determine the two equations, y equals k times x, representing the relationship. The first one has been done for you. So number one has been done. This is going off of the very last thing I did in our notes, where you write your fraction and then one of the scenarios, and then you cross multiply and solve for one of the variables. So what they did is they took the 9t equals 1v. They took 9t equals 1v. One time they solved it for the v, which is really already done. 1 times v is just v. I didn't need to change color for that. So 9t is equal to your v. So that's one of the answers, which was this one. I just have the sides swapped. And then the other one was you take the 9t equals 1v and you actually have to solve it. You divide both sides by 9. And you get that t is equal to 1/9 times v. So that's this one. It's a matter of which one you prefer to be solved for. If you have a problem where they're going to keep asking you for the v's, you want it to be solved for v. If you have a problem where they ask you for a bunch of t's, the tax, then you would want it to be solved for t. You want your equations to be as easy as possible. It means you want to be solved for the variable they ultimately ask you about. So they set t over v. So this was them using their words, tax over value. They said tax over value equals, and then they put in the numbers from the scenario they gave us. They reduced it just to make the numbers easier, and then they cross multiplied the t times the 9 and the v times the 1 to get this. And then the two, they said determine the two equations. That's where it's just one time you solve for t, one time you solve for v. Again, in the real world, there's no reason for you to solve for both. Pick one and stick with it. Which one should you solve for? The one they ask you questions about. Now, they're not asking about any questions in here, so that part's irrelevant, which is why they ask you to do both for good practice. All right, so let's come off of annotate, put this back where it was. Okay, so number 2. euros to pounds. So they say 113 euros gets you 100 pounds. So you could write, we'll do E for euros over P for pounds, not LB, that's a different type of pound. So we're deciding to go euros over pounds. I could have gone P over E, it doesn't matter as long as I'm consistent. Equals, write the number for the euros, which is 113, write the number for the pounds, which is 100. There's no reduction here, so go ahead and cross multiply. After you cross multiply, you'll get 100 times E is equal to 113 times P. Then from here, you solve for either E or P. Again, if this was a bigger problem, maybe I say, all right, well, if we had 1 pound, how many euros would we get? That means it would be best for you to solve for E. Or if I say, if I gave you 2 million euros, how many pounds would that be? That means prefer to solve for E, you divide both sides by 100, which would give you E equals 113 over 100p. Or you could do it this way. You take your 100e equals 113p, and you instead divide both sides by 113 if you wanted to solve for p, which gives us 100 over 113 E is equal to P. Again, either of these could be the one you use. They asked for both, so we did both. This is literally doing y equals kx. Now you have y equals kx. You know that k is that 113 over 100 in this left scenario. E is the euros is what you've called y, and pounds is what you've called x. Or if you did it this way, again, the thing by itself is on the right, so that's the y, and then the k and the x. So k is the flip-flop of it. Euros is now x, and pounds is now y. That's the benefit of doing something this way. You don't have to think about the placement of things. That's why I'm giving you all these different scenarios. They're all awesome in their own way. All right. Number 3, the total cost of buying tickets to the number of tickets. So 6 tickets cost you 24 bucks is what this is saying. And if you buy more tickets, if you bought twice as many tickets, the cost would double because they're all the same price. So I'm going to choose to go cost for C for cost. I'll actually label my abbreviations this time. I'll be very meticulous. And then I'll do T for tickets. So I'm going to go C over T. I could do T over C. Doesn't matter. Just be consistent. So make sure you put the cost of 24 in the top, the number of tickets, which is 6 in the bottom. Then we cross multiply, and we get 6C is equal to 24T. You could have reduced that first. I honestly generally don't. There's nothing wrong with that. But this is just the way I do things. And then it's a matter of, well, if you want to solve for C, you divide both sides by 6, which would give us C is equal to 6 goes into 24 4 times, so 4t. That would be one answer. Or you take your 6C equals 24t, and you divide both sides by 24 instead. Now that does not divide perfectly, but it does reduce to 1/4. So 1/4 of the number, or sorry, of the cost of tickets would give you the total number of tickets you buy. So this would be the other version. Look at that. K was 4 in one scenario, 1/4 in the other. Finally, height of a digital photo in comparison to the width of a digital photo. So let's go H for height, and let's go W for width. See, I'm not using Y and X here because I have more appropriate letters, just better letter choices. I still could use Y and X. I could call Y the height and X the width, and then I go Y over X instead of H over W. It's your choice. Now, my math lab might tell you what letters to use, so pay attention. All right, so height over width, or width over height as long as you're consistent. Because I did height over width, I go 3 over 5. If you did width over height, you'd go 5 over 3. Cross multiply. So you get 5h equals 3w. Depending on which one you solve for, divide by either 5 or 3. If I want to solve for h, I divide by 5, which tells us h is equal to 3/5 W, or if I want to solve for W, I divide by 3. And I only, in the real world, only have to do one of these. So if my boss man gave me 10,000 different heights and wanted to know what the width should be, I would use this one. Again, if my boss gave me 10,000 heights or even one height, I would use this one because the W, the thing I want, is by itself. If my boss gave me 10,000 widths, I would use this one because the H is by itself, the thing I need. That enables us to use Excel to very easily type a formula once, fill it down 10,000 times, and boom, we go home in 15 seconds if we've got that skill sharpened. All right, so that is
And silly me, my mic was off. Oh, I just talked for about a minute and you didn't hear a single thing. Okay, so that was 2.3. As I was saying, we're about to pick up in 2.4. We definitely won't finish this section today. Yeah, y'all are starting to catch it now. So we won't finish 2.4, but we will get a decent head start. And I did want to point out that there was a typo in one of the last problems from that guided activity, the tax. If you notice on the top line, it said the property tax was $2,000, but then when we actually saw the math, it said $20,000. A very, very minor issue while we're going through notes that would not pop up in homework or tests, obviously. And especially, hopefully in real life, no one's paying $20,000 tax every year on a $180,000 home, because that would be about 11%. Very, very ridiculously high tax rate. But, you know, who knows what happens 20, 30 years from now in the future. So again, I just wanted to point that out. Now let's pick up in 2.4.
2.4, financial literacy. So one of the many reasons I like teaching this quantitative reasoning course is that we do spend a decent amount of time. Well, first of all, we spend a decent amount of time using Excel, and Excel is something that many office jobs end up using, and not necessarily in big crazy ways, which we don't do Excel in big crazy ways. We generally just lay some numbers out, apply some formulas, make some charts, and everything's pretty nice. There are certainly jobs that use the crazy, super crazy built-in Excel functions, and you have to learn to be almost like a programmer, but I'm not here to teach you that side of things. So that's one of the reasons I like this course. But the one I was getting to now is that we teach a lot of finance stuff, things that you don't really learn in high school, things that you don't learn in a traditional college math class. I had a lot of math classes in college. I mean, I have a master's in it, so I spent like 5 years studying almost exclusively math and variations of math. And yet I never did 1 ounce of talking about, you know, how you should pay or whether you should pay a mortgage off early, get a 15 or a 30-year loan, the formulas behind them, although I did use the idea behind it in other ways. We didn't talk about stocks and bonds and personal investments and pensions and anything like that at all. Now, if you're a business major, I'm sure you get into that. It's pretty obvious that you would get into that. But this is just something that's lacking in a lot of people's lives, and it's one of the many reasons that we have kind of a crisis that 9 out of 10 people can't retire the moment they're supposed to, because all they'd have left is Social Security. They've never put anything into retirement, or they put very minimal into retirement. And some people have pensions, which is a fund your employer sets up and just kind of pays you automatically. But honestly, the way of the pension has gone away. There's not a lot of companies left that offer it, and there's various reasons to that. And it's my personal opinion that a pension isn't that great anyways, especially now that some of these systems have been broken. And we don't need to get into all those details, but doing your own kind of Roth IRAs and 401ks and personal brokerage funds, that's much more the way to legitimate retirement versus just hoping Social Security is going to, let you coast until you're done. Social Security itself is kind of a broken system as well, and I won't get too heavy into the politics of it since this is recorded, but Social Security was set up to help poor people essentially back in the FDR times. And it helped them a little, but it ended up helping rich people more because Social Security, the amount that you earn, is proportional. Hey, that key word that means, as one thing goes up, the other goes up. So it's proportional to the amount of money you've made over your life. So if you're poor, you haven't made that much money, you're not going to get that much Social Security. If you're rich, you've made a lot of money, you'll get a lot more Social Security. Also, statistically, you can look this up and confirm it. Don't just trust me blindly, but rich people tend to live longer on average. So that makes them even more money off of Social Security. That's what I mean by it's kind of a broken system. Also, is Social Security going to be around for another 30 or 40 years? There's a lot of debate about that. Most people say if it is still around, it's going to be at a reduced benefit, like 50 or 75% of what it claims you would make currently. But again, not going to get into anything else past that. Let's just kind of introduce some core ideas. So we're going to talk about stocks a little bit throughout this course, a little bit today, a lot more at the end of the semester. And one thing that you would find in a stock table, and we'll see a stock table today, if we make it on time, I think we will, is a PE ratio. PE stands for price to earnings. P for price, E for earnings. PE ratio. So it's a ratio, it's a fraction of the price. And when they say price, they mean price per share. So whenever you buy a stock, you have to pay a price per share. So for instance, Apple is about 115 bucks a share right now. Amazon's about 33 or 3,400 bucks a share. Maybe it's 3,100 actually. I think it's a little lower. So one share of Amazon costs a lot more than a share of Apple, especially since Apple just did a 4-1 split or 5-1 split, one or the other. Maybe it was Tesla that did the 4-1 split. Doesn't matter. These are irrelevant. I'm talking above a lot of people's heads, I'm sure, and that's not my intention. The point is, stocks have different prices. And it's not always just a better company has a higher price. There are lots of good companies that have much lower prices, and this can be achieved in various ways. But the point is that a company has a price per share. Also, at the end of the year, they can calculate earnings per share. So earnings is your profit. So if you take your total profit and divide it by the number of shares of stock a company has, whether it's 100, 1,000, 10 million, 10 billion, and it's usually in the millions and billions. If you divided those two things, you'd get the PE ratio. And historically speaking, this has been a good way to measure whether you should purchase a stock or not. Now, this is a way. This is a way. I'm going to highlight that letter A. That's not a highlight, is it? That's blacking it out. Highlight. This is a way to measure whether you should purchase a stock or not. This is not the end-all be-all. I will even speak from my personal investments, which I don't have a lot of, but I don't usually look at the PE ratio that often. I do for some companies, but for other companies, I'm like, I know this is a good company. I know it's going to grow. So I'm going to buy it even if the PE ratio seems out of the correct range. But the simple idea is that if you have too low of a PE ratio, as we will kind of talk about later with an example, it means that the company could struggle. Too low of a PE ratio might mean that the earnings that the price per share is really, really low. And when you have a really, really, really low price per share, like if you're in the dollar range, you can be what's known as delisted. You can be removed from a stockbroker, and then people can't buy or sell the stock anymore. So it just goes to zero and the company goes bankrupt. So if you get too low, it means that your company is basically in a threat of just shutting down. You know, you hear about all these penny stocks, and some people gamble on penny stocks, but that is a really high gamble, because a lot of those companies just disappear instantly and you lose your entire investment. Whereas you bet on someone like Apple or Tesla, you might lose money today, you might gain money tomorrow, but Apple's not going to just disappear in a couple of days. Tesla's not just going to disappear in a couple of days. So too low of a PE ratio could have been from the price per share being just ridiculously low, and that means the company could struggle. But also, if it's too high, then the price may not be worth the investment. The price per share may just be past the point of worth being investing. So like I mentioned, Amazon's like $3,000 per share roughly. Now, does that mean that you're not going to make money on Amazon? Not necessarily, but it could be an influential factor that people go, well, Amazon's 3,000, Apple's 100. I'm going to buy my Apple for $100 because I've only got $200. Now, that mindset actually doesn't really go in today's world anymore. 20 years ago, it was a really accurate statement. But now we have this thing known as fractional shares, due to all these other investment companies kind of coming up and making people like Fidelity really have to fight for their worth. So now, instead of having to buy one share, you can buy like a tenth of a share or 100th of a share. So if you wanted to just buy $30 worth of Amazon, you can with the right broker, and most brokers allow it now because they had to. People like Robinhood came in and changed the game. And I know I'm throwing a lot of these investment names at you, and you'll get a list eventually by the end of the semester of some good ones. So PE ratio is one way to say, well, maybe I'll buy this company, maybe I won't. And it's kind of a porridge situation. There's too hot, there's too cold, and then there's just right. And for the third time, you might see a PE ratio that's just way out of that porridge just right zone, and the company's still making money. Or you may see a company have just the right PE ratio and they still end up losing you money. Anything's possible. It's just a historical way of doing things. All right, so that's something having to do with stocks. Oh no, I didn't pull it up. Let me go ahead and take the time to open this. I need the guided activity. I'm just going to pull from the generic one, not our direct course, guided, nope, e-text, chapter 2, guided worksheets. There we go. And then all the way down to 2.4. So there's a few other definitions up here that, again, we don't really test on definitions in this class. That's not the point, but it's a good thing to talk about them. So we talked about PE ratio. We talked about how stock is a portion of a company that an investor can purchase, and they're measured in units of shares. So if you have one share versus someone else owning 10 shares, that person owns 10 times as much of the company. So if that company doubled in value, the person who owns 10 times as much will gain 10 times as much as the other person. Dividends, so stock prices go up and they go down. Some of them go up weeks on end, some of them go down on weeks on end, some of them go all over the place based on the market. They all might kind of do the same thing one day and then the next day. They might go up, they might all go down. But dividends is another way that you can make money off a company. It's not just based on the stock price going up, but some companies pay dividends. So this is money that a company pays out to its shareholders due to earning profit. So if you have a profitable company, say like Amazon, and I use Amazon as an ironic one because they don't pay dividends. So if Amazon was making profit, they could then pay all their shareholders, they could choose to pay all their shareholders some of that profit. And they do a little math to figure out how much they should pay them. Some companies pay lots of dividends because they're very nice. Some companies pay very little dividends because they're less nice. So Amazon in particular does not pay dividends, but there are plenty of companies out there that do. and like I said, some companies might pay 5 or 6% dividends. Some it's like 0.1% or 0.2%. Share is just a unit of a unit used to denote owning a part of a company. Price per share is the price you pay per share. That's a ratio. Price top, shares bottom. So if a company is $10 per share, you wanted to buy 2 of them, means you'd be paying $20. You double the number of shares, you double the price you pay. Retirement plan, this is something that most Americans don't have. That's the true definition. No, I'm just kidding. It's a fact, but it's not the definition. It's just a plan. And it could be any plan of saving and investing money for your retirement after working. The money you save or invest is what you will live on when you stop earning a paycheck. So the idea is you need to build up a big old moat, a big old lake of dollar bills somewhere so that once you stop working, once you start earning money, you can just use those dollar bills to live for the rest of your life. And hopefully you're still investing those so that they're regenerating while you're using them. It's called making your money work for you. And this is something that every one of you should start tomorrow. And I know for some of us that's extremely difficult to do and to consider while we're in college without a job, or while we're just making ends meet to pay for 3 kids or anything like that. But there is always, I can't say always, there is almost always a way that you can take $5 a day or $3 a day and just push it to the side and not spend it. There's lots of different ways. You go to Starbucks every day, you spend $5 on a cup of coffee and a cruller or something like that. Well, instead of doing that, go buy bulk coffee at the grocery store, which will cost you about 20 cents a cup instead of $3 or $4 a cup. Most people that go out and buy coffee generally don't get just 1 cup either. It's multiple cups. Get your little pastry from the grocery store, or maybe even eat a healthier snack. Not telling you how to do things. And if you did that for 50 years, you could have $1 million potentially. And that's not even an exaggeration. We will do that math problem this semester. I think I've already alluded to that. A quarter is just 1/4 of a year or 3 months. And this is basically how a lot of companies will post their projections and numbers and stuff like that, how well they've done. Earnings is profit. Earnings is money a company has made over a fixed period of time. Profit is the same thing. Earnings and profit are pretty much exactly the same thing. So earnings is just also known as profit. Profit is also known as earnings. Earnings per share. So this is just profit per share. This is also an abbreviation, EPS. EPS is earnings per share. PE ratio is price to earnings ratio. So when you see some of these abbreviations, if you know your words, if it's not the first time you put your eyes on it, then it should sound familiar. And then a stock quote is just, it gives all, I'm not gonna say all, but a bunch of different information about it, like the price per share, what it's done over the past day, how many shares they traded in the past day, what their 52-week range has been, what their high and low has been for a day and a year, dividend, earnings per share, yield, little charts, all sorts of things. All right, so on this screen, you can see that they do a price to earnings calculation for Apple and Amazon. And you might be thinking, well, Mr. Beckner, this guided activity was printed a few years ago, and you were saying Apple is like $100 a share right now, and on this sheet it's 220. So Apple's lost half of its stock price in the past couple of years. And the answer to that is no, because as I just mentioned, they did what's called a stock split, which just makes the numbers smaller, and it's for very artificial reasons, especially in this world because of fractional share purchases. So before the split, Apple was getting close to $500 a share. It was like $450, and then they split it and it became $125. And it was a 1-to-4 split. It's got to be a 1-to-4 split to make that happen. So if you are looking at this number, this 220, Apple's price per share now is really like 460. But again, there was a split. It's just an arbitrary way of changing the numbers. When they do that, all of the numbers in the past change. So if you consider that split, this number should really be $55. If that all confused you, just ignore it and look at the number and smile. So they say every company has a different number of shares. For instance, 487.7 million shares of Amazon and 4.8 billion shares of Apple. And again, this was the time this was printed. That has changed since then. Fewer shares can contribute to a higher price. Every company makes a different amount of profit per year. This is reported as earnings per share. So the EPS, earnings per share, for Apple was $11.53, and for Amazon it was $11.01. So they seem like they're pretty close. They're earning about $11 per share of the company. Maybe that's a good thing. I don't think that's a bad thing that they're close to each other. But what we can do is we can take those values along with their price per share. We can do a ratio of them and see what their PE ratio comes out to. So we take the price per share, which they said down, I thought they had it up. Yes, they do. They have it up here at $220.65 for Apple. And then we're going to divide it by its earnings per share, which was $11.53. You can see that done right here. You would just jam those in a calculator and you'd get 19. Amazon, however, Amazon had that very, very high price of $1,800 roughly per share. And then the earnings per share was $11.01. And when you divide those, you get 162. So you can see that these two numbers are wildly different. One of them is about 20 and the other is about 160. Now, one of those is about in the sweet spot of buying, the other is not, and yet both of them were extremely profitable companies for the past 2 years and the past 8 years before that as well. They just keep making lots of money. A lot of people talk about how you should have diversified stocks and bonds and everything for your investments. I know of a couple people that basically just invest in Apple and Amazon and ride that to the bank. I'm not telling you how to invest your money. I'm saying there are many different theories, but these two companies in particular keep growing. Maybe they'll stop one day, maybe they won't. Maybe they'll take over everything. We don't know. Amazon sure seems to be doing a good job of that. But again, the fact that PE ratio of 20 and 160, what this is saying is that people are paying 162.5 times what Amazon earns per share versus only 19 times per share in Apple. So the idea there is that people are overvaluing Amazon in one way because they're paying 162 times what it's earning, whereas Apple's only paying 19 times what it's earning. Now, again, that doesn't mean that the company can't just keep kicking butt and making people scratch their heads and going, why is this still happening? But it's a traditional way. So I will just go ahead and spoil this. This 20 number, this 19 number is a lot closer to the porridge, the sweet spot. This 162 is way out there. It sounds a little ridiculous. So obviously people think Amazon has huge growth potential to pay this much in its shares, and they just keep proving that they do. Because again, at the time of this printing, it was at 1,800, and now I'll pull up my stock ticker on my phone. Now it's at about 3,200. So it's almost doubled since this page was printed a couple years ago. That's insane. Okay, so here's what a stock ticker looks like, or a stock quote. Some people call it the ticker, some people call it the quote. Again, I don't really care what you call things. It's not super important to know the deep, detailed names. It's understanding how to use them and apply them. So the PE ratio is one of the most common statistics used to assess the value of a share of stock. Again, it's not the end all be all, it's a way. We will discuss this stuff more in chapter 9, but for now, we're just going to kind of go with this PE ratio idea. And I'm going to need to do this, and then let's just pull up this. That looks pretty good. Okay. All right, so price. Now, this is not super well labeled. It just says price, but more technically, it should be called price per share. But a lot of these don't say price per share. They'll just say price. So that's the price you would pay for one share of stock. Then we have change. So over the past day, it went up 0.17. So that means it went up 17 cents. Then it shows that change as a percentage. And we're going to start learning how to calculate percent changes in chapter 4. But for now, we're just going to take it at face value that it increased almost 1%. This says that 8 million shares were traded. In that day, they were traded between 28.23 and 28.43. So at one point it was a little higher than what it closed at. At one point it was a little lower than what it closed at. But ultimately it went up 17 cents from open to close. Beta, we're not going to talk about. This 1 year percent change says it's gone up about 10% over a year, which is pretty good. Nobody's going to complain over making 11% on something in a year, especially when your savings accounts are getting you like 0.5% right now. That's 0.5%, not 5%. Price to earnings. So this is the literal PE ratio. The X, you kind of ignore. It just says it's 8. The earnings per share, or EPS, is 3.55. Dividend and yield. So the dividend says they're paying $1.72 per share, which is 6.06% of a dividend yield. These two numbers are actually tied to each other, and we're going to show that. And they give you a chart of the past year. If you're online, you can change this to a day or to a decade and all sorts of different ranges, depending on what app you're using, what site you're using. All right, so getting to the point, they ask us to, number 1, compute the ratio of the price per share to the earnings per share. So they ask us to make a ratio. So they want us to make a fraction, and they want us to do the price per share in the top to the earnings per share in the bottom. And then they want to scale the second quantity to 1. So for number 1, we're doing the price per share to the earnings per share. That's how we're setting our fractions up. It's going to be price per share over earnings per share. But we're not just going fraction over fraction, because they say to scale this. To scale means to set up a proportion. So what we'll do is we set a fraction equal to a fraction, where the left one will have the numbers from the table, the price per share and the earnings per share. What's the price per share? That's the 28.40. The earnings per share, use your eyes. Oh, that's this, right? No, it's not that. Oh, it's this, right? It's the beta. It's definitely the beta. No, it's the thing that says, pay attention, earnings per share. Earnings per share, and that number is 3.55. How did I know what the price per share was? I used my eyes and I paid attention. How did I know what my earnings per share was? I used my eyes and I paid attention. But then they said to scale the second quantity to 1. What's the second? Top or the bottom? It's the bottom. It's first in the top, second in the bottom. So when they say to scale it to 1, that says to put a 1 there. It doesn't say, this is not what it says. It doesn't say just turn the 355 into 1. Scaling something means to build a proportion and to scale the specific number to 1. If they had said to scale the first quantity to 1, then I would have done this instead, but that's not what they asked. Oop, too far. There we go. So with that being a 1, that means we can call this any letter we like. We're going to call it X. How do we solve this? We cross multiply. When we cross multiply, we'll get 28.40 times 1 equals 3.55 times X, which is just 28.40 equals 3.55x. Then we're going to divide both sides with 3.55 to solve for x. Again, you've got to know how to do your very, very simple algebra, which says that when we do that division, let's pull out a calculator. Oops, C for calculator, which just happened. I've never seen that screen before in my life. I hit my mouse scroll wheel and that happened. So now I know 28.4 divided by 3.55. And we get 8. We get 8. So 8 is equal to x. What is x? X is the ratio of the price per share to the earnings per share. The price per share to earnings per share. The price to earnings. Price to earnings. Look right here. Look in the guided activity where I'm hovering over now. Price slash earnings. That means price on top of earnings. We calculated it to be 8, and the table actually said that to begin with. So if you understood the words and everything, you might have been able to just say, well, it's 8. We're doing price over earnings, so they told us price per earnings is 8. But guess what? That's exactly how the table finds this. Now, do their calculations have to do it this way? No, they could have set up a y equals kx scenario and found it that way. That would have also been perfectly valid. because all of these things in this table are proportional. All right, so number 2, the earnings per share or EPS statistic is the ratio of the profits the company made, earnings, profit, remember those two words are interchangeable, but we don't like to go profit per share because that would be PPS, and that's price per share. It would be the same abbreviation for two things. So that's why people really like EPS for that one. Earnings, profit, interchangeable words. So let's use E so that we don't have the same abbreviation twice. That would be extremely confusing. So the earnings per share is the ratio of the profits, aka earnings, the company made for the previous 12 months, for the previous year. That 12 months not going to have anything to do with the problem, to the number of shares. Earnings, shares. Profits are earnings, shares are shares. So we're doing profits divided by shares, or earnings divided by shares. The word per means the second thing is in the bottom. If there were 5.9 billion shares available, use the EPS statistic given to compute the profits that AT&T made. So this company's profit margin is not in this chart or table or whatever you want to call it anywhere. It's not in there. There's nothing that says the company's profit. But if we know how many shares of the company are available and we know the earnings per share, we are able to calculate this. So let's write out what this says. The earnings per share is, so this is number 2. The earnings per share is means equals in math. Is always means equals. So the earnings per share is the ratio, so I'm gonna make a fraction, of profits or earnings to the number of shares. So it's earnings, aka profit, over the number of shares. All right, over 12 months. I don't see anything having to do with time here, so let's not plug that 12 anywhere in. They tell us that there were 5.9 billion shares available. That's also not in this table. I've always felt like that's something that should be in the table. They say how many shares were traded over the previous day, but not how many shares there are total. So there was 8 million traded yesterday, but there's 5.9 billion, so that's about 1,000 times more available. Well, that's one of the numbers that goes in this. There were 5.9 billion shares. That's the number of shares. That's this bottom number. That's the 5.9 billion. So I'm going to take this thing and just rewrite it. But instead of number of shares, I'm going to write 5.9 billion, which would be 5,900,000. So this looks like 5.9 million, so I need 3 more zeros. Know your millions and billions, that'll really mess you up here. That was the number of shares. It was told to us inside of the problem. The question they have is, compute the profits, compute the earnings. That's this. They have asked us to find this thing because it's unknown. It's not just staring us in the face. That's what we can call our X. And you go, well, hold on. How do I do this division if there's an X here? Well, they said to use, why does that not work when I use my pen? Use the EPS statistic. They gave us the EPS. The EPS was 3.55. So this number right here is 3.55. So this is actually an equation. 3.55 equals X over 5.9 billion. How do we solve X divided by a number? We multiply. So we need to multiply, and I'm going to abbreviate this for space, 5.9 billion, 5.9 billion, multiply, multiply. So that the 5.9 billions cancel on our variable side, giving us just an X. Let's pull out our calculator. Why did I close it? That was silly of me. So let's see, 5,900, and then 6 more. 1, 2, 3, 4, 5, 6 times the 3.55. Let's see if this gives us something not in scientific notation. Good. So we get 20.945 or 20.945 billion. So 20, 945 45, comma 000, comma 000. X is a dollar amount because it's profit, so that's 20 billion, or you could say 20.945 billion. In the real world, nobody cares how you express your numbers. My math lab would ask you to write it in billions or to write all the zeros, so just pay attention. So this company over the past year profited $21 billion, roughly, just rounding it out. Now, profit is not just how much money they made. Profit is the difference of what they earned and what they paid. So you have income and expenditures as a business, and profit is the difference of those two things. It's the difference of money coming in and money going out. But this 21 billion number, this would be one of the values the company would base off of if they were going to give out dividends. So if they said, all right, well, we're going to share 1% of this with our stockholders. So they take 1% of this and then divide that by the number of shares and then give that to everybody who owns a share. Okay, so if you own one share, you would get, let's say you did all that math and you've got $1. So if you own one share, you get $1. If you own 100 shares, you get $100. All right, problem number 3. This is going to seem like a big detour for a few minutes. The importance of this problem is way outside of just this relationship here. This is going to talk about a very core idea of math. When you have fractions, if the top goes up or goes down, it causes an effect to that final ratio. When the bottom goes up or down, it causes an effect to that final ratio. That's what we're actually going to be studying for this problem. But we will use that study and give it the specific language for problem number 3 in the end of it. All right, so what am I rambling about? The share price changes constantly as people trade shares with each other. If there are more buyers than sellers, the price goes up. If there are more sellers than buyers, the share price goes down. And this is pretty much how stock works. So if 90% of people out there are trying to buy stock, it means that the people selling are like, nah, I don't really want to sell. I want to buy more right now. That drives the price up because demand is high. The demand to buy is high. And you can see the same effect in the real estate market. Or if everybody's got a bad feeling about the stock market for the day or the week or the month or the year, then maybe everybody's trying to sell and unload their stocks. But if everybody's selling, who's going to buy? So if everybody's selling, and if you've got 90% of people selling and 10% of people buying, they're going to go, nah, lower that price. Nah, lower that price. And that price is going to drop and drop and drop. Okay, so that's a nice idea. If there's more buyers than sellers, price of stock goes up. If there's more sellers than buyers, price of stock goes down. The point of this whole problem, though, is what are the 2 different ways the PE ratio can increase? Question number 3 doesn't even need any of the sentences before what I currently have highlighted. What are the 2 different ways the PE ratio can increase? Now, this has nothing to do with any kind of deep financial analysis.
Some quick video editing because Word crashed on me there. Oops. And here we go.
We are doing something known as what-if analysis. This is something I mentioned that Excel is amazing for because we can just quickly type a number and see what happens. We can type another number and see what happens, or we can create an entire table of numbers and see what happens, kind of like that BMI table. Hey, if you're this weight and this height, what's your BMI? If you're this height and this weight, what's your BMI? If you're this height and this weight, what's your BMI? If you're this height and this weight, what's your BMI? It's the same idea as when we had that car loan where you're looking at like 5, 6, 7, 8, 9, 10% loans and taking that loan for 1, 2, 3, 4, 5 or 10 years or whatever that range was. If you do this, what happens? If you do that, what happens? So we're just going to play with a bunch of numbers at a time. For this particular problem, we are going to set up a fraction with numbers we choose. See what the answer is. Then, so this will be our baseline. So I'm just going to take two numbers and I'm going to divide them. Maybe 100 divided by 5 and I get 20. Or 100 divided by 10 and I get 10. Whatever that number is, I'm going to hold on to it. That's going to be the thing I compare to every time. Then what we're going to do is we're going to take the top. So then we will play with the top. One time, make it bigger than the original top. Time, and I got to hit enter. One time, make it smaller. One of these scenarios, what we desire. What do we desire? We desire the PE ratio to increase. So let's ignore the whole idea of PE ratio. Let's just say we want the ratio to increase. We want the answer to go up. So what we desire is answer to go up. So we've just come up with our own two numbers, one for the top, one for the bottom. 100 divided by 5, or 100 divided by 10, or 1,000 divided by a million. It doesn't matter what they are. It's just a baseline. You get an answer, and you hold that answer, and you say, you're my baseline. You're what I compare everything to. Then you take the top number, make it bigger one time, see what the answer changes to. Make it smaller one time, see what the answer changes to. Okay, so that's scenario A. Scenario B is we'll play bottom. Same way. And one of the scenarios is what we desire, to make the whole thing go up. Then make a statement about which things gave the desired answer and relate to PE ratio. So I'm going to start with two things. What's PE ratio? It's price and earnings. So I'm going to start with a price of, I said 110, so let's go with that. $100. And let's say earnings or profit for $10. This is just me making up two numbers. If this was normal class, you'd be in groups doing this. This does not bode well to a discussion board, unfortunately, so you're just going to see me do it instead. And I really don't like that, but it's something we need to see. But I would really appreciate it if all of you, which will end up being like 3 of you probably, and I just know that, if you tried this on your own, you, instead of using 100, maybe you say, I'm going to use 50. And instead of using 10, maybe you use, I don't know, 20. It doesn't matter. Come up with your own numbers. Sorry for that. So then our PE ratio would be 100, because that's the price, to the earnings, which is 10. And 100 divided by 10 is 10. And I'm going to put this in a different color. This is our baseline to compare. Yes, I know it's coincidentally the same as the earnings. Do not take that as any kind of important factoid. If you don't like those being the same, do 105 and then you'll have a 20. Easy way to fix things. So this is our baseline. So now what we're going to do is we're here. Then we're going to play with the top. So in this 100 over 10, I'm going to one time change the 100 to a bigger number. Then I'm going to one time change that 100 to a smaller number.
And that is where I'm going to leave things off. I'm actually leaving it as a cliffhanger intentionally because I would like y'all to try that on your own if you have time. Now, when we come back to class on Tuesday, we're going to go through that whole thing. I'll even play the last couple minutes just to as a reminder, but try that out again. I chose to do 100 on the top and 10 on the bottom as my baseline values. You can pick any two numbers you want, and a lot of students will kind of stall out and go, well, what numbers do I use? And again, I literally just said to start out, you use anything you want. And then you'll only play with the top number, make it bigger, make it smaller, see what happens. And then you only play with the bottom number, make it bigger, make it smaller, see what happens. So again, we will cover that completely using my numbers next time. But for now, focus on all of this stuff first. Of course, the actual assignments need to take priority. Besides that, if you have any questions, you are free to email me as always. And yeah, have a good weekend. We'll pick up where we left off in 2.4 next time, but for now, we are done with everything up to 2.3. And you should also see that the chapter 3 and 4 notes to share are now available, so you can start peeking your eyes at those. All right, take care, everybody.